Operations management is the disciplined design, coordination, and continual improvement of the processes through which organizations transform inputs into valuable outputs. It concerns the practical logic of production and service delivery, yet its significance extends beyond efficiency, for it shapes quality, reliability, responsiveness, and strategic resilience. In a manufacturing firm, the discipline governs the flow of materials, labor, and information. In a hospital, it influences patient throughput, waiting time, and clinical accuracy. And in a digital enterprise, it directs the architecture of platforms, data, and support systems. At its conceptual core lies the conversion process. Resources such as capital, personnel, technology, and raw materials are acquired, organized, and transformed into goods or services. This transformation is never purely mechanical. It requires decisions about capacity, location, layout, scheduling, inventory, forecasting, and quality control. Each decision contains trade-offs. Excess inventory may reduce shortages, but increase holding costs. A highly standardized process may improve consistency, but diminish flexibility. The central intellectual task of operations management is therefore optimization under constraint. The field is often distinguished by its concern with systems thinking. An operation is not merely a collection of isolated tasks, it is an interdependent system in which changes to one stage influence performance elsewhere. A delay in procurement can disrupt production, which may then affect distribution and customer satisfaction. For this reason, managers must examine flows rather than fragments, and they must identify bottlenecks, sources of variation, and points of leverage. The most effective interventions are frequently those that improve the whole system rather than the most visible component. Quality management occupies a prominent place within the discipline. Quality is not limited to defect reduction. It also includes conformance to specification, durability, usability, and the extent to which outputs meet customer expectations. Modern operations increasingly rely on preventive rather than corrective approaches, using statistical control, process mapping, root cause analysis, and continuous improvement methods. In this framework, variation is not merely an inconvenience, but a signal requiring interpretation. A process that appears stable may still be incapable of meeting standards, while a process that seems efficient may conceal hidden fragility. Another essential concern is timing. Operations are judged not only by what they produce, but by when they produce it. Lead time, cycle time, and on-time delivery have become strategic indicators because contemporary markets reward speed and dependability. Firms that can adapt rapidly to demand shifts possess a competitive advantage, especially in environments characterized by uncertainty and short product life cycles. However, speed without discipline may undermine quality, while caution without agility may render an enterprise obsolete. Effective operations management reconciles these tensions through design and governance. The contemporary importance of the field has been intensified by globalization, digitalization, and sustainability pressures. Global supply chains have expanded the geography of operations while also increasing exposure to disruption. Digital technologies have enabled real-time monitoring, predictive analytics, automation, and data-driven decision-making. Sustainability has introduced additional criteria, compelling organizations to account for energy use, waste, labor conditions, and long-term ecological impact. Accordingly, operations management is no longer a purely internal managerial function. It is a strategic and ethical practice with consequences for firms, workers, customers, and societies.